The size of a glacier is dependent upon balance between the amount of snow added each year and the amount of ice lost each year by melting. We call the amount of snow added accumulation, and the amount of ice lost ablation. During the start of an ice age, as the climate is becoming colder and colder, more material is added to the glacier by snowfall than is removed by melting. So the glacier grows year after year. For an ice sheet, accumulation happens in the center of the glacier and melting happens at its margins. The ice sheet that covered North America accumulated in Canada and flowed south into Wisconsin. As the snow changes to ice under pressure, the ice changes to plastic deformation rather than brittle shattering when it's around 200 feet thick. When the ice accumulated to a depth of 200 feet, an event of great magnitude occurred. A rock at the edge of the thickening ice was nudged from its position. This time-lapse simulation shows the glacier spreading like a pie crust under the pressure of a rolling pin. For thousands of years, the ice began to spread outward. The ice mass had become a glacier. From a point centered around today's Hudson Bay, the glacier crept forth, growing in thickness and size until it towered above all landforms and boasted continental proportions. The lobes of the Great Glacier flowed side by side and moved somewhat independently. One bulge, known as the Green Bay Lobe, headed south. It arrived and covered Pope Farm Conservancy around 25,000 years ago. When the climate warmed, the glacier retreated and uncovered Pope Farm Conservancy about 18,500 years ago. The great continental glaciers were the mightiest invaders ever loosed on the Earth. As the glacier advanced, it pried up bedrock, captured huge boulders, and pushed nearly everything out of its way. It pulverized, scraped, scoured, and bulldozed. In northern Wisconsin, the glacier reached a thickness of nearly 2 miles. At what is now the state capital, the glacier towered 1,600 feet into the air, the equivalent of a 160-story skyscraper. As a glacier slides over the land, it scrapes against and begins to break off pieces of rock. Rock and soil beneath the glacier get frozen into the ice at its bottom, known as its bed, and acts just like sandpaper to help erode the underlying surface even more. As the ice flows farther from the center of the ice sheet toward the margin, more rocks become eroded and broken down into smaller and smaller pieces. Friction drags along huge amounts of material beneath the bed of the glacier. Even more material is transported within the ice and eventually even on the surface of the ice. When this sediment is finally dumped near the edge of the glacier, it is a mix of many particle sizes: sand, silt, clay, gravel, and boulders all mixed together. We call this mixture of sediments till. All the stones you see at Pope Farm Conservancy were carried here from Canada by the Great Glacier. As climate begins to warm, melting of ice begins to outpace how much new ice is added by snowfall, causing ablation to occur. Melting ice sheets, like the one that covered Wisconsin, produced a huge amount of water that flowed away from the edge of the glacier. This meltwater formed local lakes as well as vast rivers that carried large amounts of sediment away from the edge of the ice sheet. Black Earth Creek and the lower Wisconsin River were ancient pathways for meltwater. Those valleys are now filled by sand and gravel called outwash that was left behind as a result. As you stand on the hilltop at Pope Farm Conservancy, you can see the terminal moraine where the glacier stopped, and Black Earth Creek Valley where the meltwater was carried away.